the fixed function pipeline of graphics rendering was working quite nice. And even many games are still only use that. And last year we had some Direct3D 8 support, shader model 1.x that worked sometimes it fails. And support for shader model 2 and 3 was starting, and also support for GLSL shaders. So a short summary was what was done. Hello? Cool. So shader support improvement and cleanup of the state management, which also last year we set each state pretty much every draw. So the game called that did a draw call, and we just reset everything. And nowadays we only set the change states. In the recent weeks, Roderick has ported our Direct3D code to Windows. I will outline that later, why this was done and how it works. And we also have better support for macOS nowadays. I call it a board. It's not really a board, but support for this platform is much better. We have multi-threaded drawing support now, and a few extra features were added. Also, we had this Direct3D 10 Sum of Code project. I will go into detail here later. Also, already mentioned in a 6 talk, we have some better automated testing now for performance, and also the tests in Wine itself were improved, and we have support for accelerated 2D drawing with OpenGL now. So some details, some new features shown with the games that use them. This is a screenshot of Half-Life 2 Episode 1 with high dynamic range rendering enabled. And what you can see, what is in use here are floating point textures, support for the high-end 3.0 shaders, gamma-corrected textures and gamma-corrected color, frame buffer writing, and also off-screen rendering with frame buffer objects. The game runs, with exception of a small fog bug that isn't visible in that screenshot, the game renders correctly, but it is still quite slow. It isn't really fast in Windows 8, but it's some 10 frames per second on a high-end system, or a medium-class system nowadays. It used to be a high-end system last year. Here you can see the high dynamic range rendering quite nice. Actually, the projectors, it works better on a real monitor, and high dynamic range images can't be caught properly in standing screenshots. A part of it is how the lighting changes when you move from bright areas to dark areas. But here it can be seen pretty nice. This is a pretty old game. It's actually the game I started hacking on Wine for, and it uses a different thread to draw the mouse pointer. And this works a bit better. This works now more or less. It still runs into driver bugs on ATI cards, and it runs into driver bugs on NVIDIA cards. But the game still isn't playable, although I hacked on Wine for 2 years now, because the drawing of the text is very, very slow.
That's good, because if it was done, then you quit, right?
Probably. You changed my priorities a bit. This is Supreme Commander, and a feature it uses is instancing. This allows the game to draw multiple. It uses it for the unit, so It draws 5 or 10 units with one draw call, and it gives quite a speed improvement in Windows. We only emulate it because instancing isn't really needed in that way on OpenShell, because draw calls are much cheaper on OpenShell than they are on Windows. But it gives a bit of improvement too. So unfortunately, when I caught the screenshots, all units were gone again, just shut down. So this screenshot doesn't demonstrate instancing really, but the game uses it. This is a tech demo from NVIDIA. It uses the vertex shader reads a texture, and this is a feature which isn't even available on high-end Windows boxes on all. ATI cards do not support it, so it is a really optional feature, but Henry has implemented support for it, and it works quite nice. So this is just a vertex texture fetch.
Okay, which does what?
This is a texture that it renders in off-screen in the graphics card, and it reads it in the vertex shader. Classically, textures were only used in the pixel pipeline, which are done per pixel on the screen. And here it can, what it essentially does is that the game can do something on the graphics card, store it, and use the generated data in the vertex shader. So it can generate some data and put it high up into the pipeline and use it on all the process down again.
Okay, where in the picture is this?
This is the water. So this is high dynamic. It's a dynamic geometry. So when you see it when the game runs, the water waves are simulated. I don't know. I can run it here, but not pretty well on this resolution. I'll try later, or Henry runs it. Maybe it's a bit. So it's used by the new DirectX 9, DirectX 10 games. It is used by BioShock and Unreal Engine 3, but it isn't even supported on all Windows cards.
What happens when it's not supported?
The game is slower.
Okay, so they have a fallback.
Or it misses some graphics, or it is slower. But it runs without even. But it gets quite important in DirectX 10 later. This is a even much older game. I think this game is how old? 10 years older. But it shows hardware accelerated DirectDraw, which Wine used to have a long time back with direct memory access, but it was removed from Linux distributions due to security concerns. So basically, if you had this enabled, the root password, it's like giving your root password to everyone, enabling the game direct access to the whole memory. And this is drawn using OpenGL, and Roderick Holmbrander has done quite a bit of work on it. Also, and the nice thing about the DirectDraw work is that it was essentially the start of DirectX 10 work too, due to the way he changed the texture upload, which uses the Direct3D 10 memory model more or less. This is Command & Conquer 3, nothing special really about this game, but we had a pretty nice success with it, because when it hit the stores, it ran from day one without any extra patches. So it was a shiny new game that just ran without any modifications to Wine.
And it's running flawless?
There are a few minor flaws, and there were a few regressions later, but okay, copy protection possibly, but I don't. This no, it's. I don't. I think you. How did you run it?
I run from my laptop.
Yeah. Okay. So the usual way to get past it. The only one that uses to work on Wine. And this is a 1-year-old game approximately, and it also uses quite a few advanced features, and it looks quite nice, actually, in my opinion. Settlers 2 was one of the games I started hacking. I started to play computer games with.
Yeah, well, it looks kind of weird by modern standards, but
Yeah.
it's the Settlers 2 look, so that's fine.
Yeah. So I don't have any comparison screenshot with the old DOS game that is 15-year-olds now.
No, that can't be 15 years.
I think I played it in 1996, 10 years. I think somewhat I remember 1994, but I'm not sure. It's a DOS game, so not really interested for Wine. And now I have some screenshots of really shiny new games, 1 month old, but take them with a grain of salt. So they do not, it doesn't work properly well, but what is Bioshock, it starts, it crashes on many computers, it crashes on just hard kernel panics, more or less, my laptop, due to a graphics driver bug. And it is said to run pretty bad on Windows too. But Anastasius Vogt got it running on his computer, no kernel panic there. And it ran slow, but it rendered pretty, I don't know how it's supposed to look like on Windows, but it looks pretty nice on Wine too. And what is really cool about this too is that from Direct3D point of view, I only had to put a one-line hack in to get it started. And it pretty much worked out of the box with what we had. So a new game that is 1 month old. So it pretty much works quite nice already. You see in the console there are a few fix me scrolling around, so it's not perfect yet, and it's pretty slow. But I think it's a quite nice success. This is a screenshot some of Code students sent me. The main menu isn't really interesting, but he says the game fails later due to network stuff. It just fails to connect to the server. But it starts up at least. Crysis is more or less the Far Cry successor.
Yeah, we're working on the network bug, but it's kind of really hard to get good output from users on that because they're like, whoa, they installed a new update and it works with those kind of funny patches I tried. So can you try one of those without the update and one with the update?
I know all that stuff.
It's really hard to fix it because you never get decent input, and I don't have a box that will even kind of try and run that.
Yeah, I think what it renders here isn't really interesting. Once we get in-game, we will have loads of failures on the graphics side. So I would be really surprised if it runs properly. So after showing some screenshots, but yeah. So the non-screenshotty stuff is like we have brought that Direct3D code to Windows, and the motivation of this was to test it as a separate component and split it up from problems in the rest of the Wine code. And it also allows us to verify it against the conformance test from Microsoft. For one part, having this as a Windows program or Windows code is a legal requirement, and it is a technical requirement too, because we need the reference rasterizer running, and this will never work in Wine because the interface is not documented. And Wine Direct3D now uses our OpenGL, the OpenGL interface implemented in Wine. So it uses VGL instead of GLX directly. This will allow us later to add support for the Apple OpenGL library. And there are some if-def tricks in the headers and the code to avoid the performance penalty of going through OpenGL of tiny functions which just call the library. So Wine Direct3D uses VGL to set up the frame buffer and that stuff, but it later on calls directly to the Linux code. So we have the extra abstraction layer without any performance penalty. I mentioned the macOS port. It isn't a real port really, because it just works with an X server. But I have added support for a few macOS specific extensions. For one part to work around bugs in the code, but we also get a few advanced. There are a few advances of this. So there's one feature, the event queries which we implement with that, and so on. And also I got rid of a few Linux-specific assumptions in the code. When the code was just written for one platform and things were hard-coded that shouldn't be hard-coded. And there will be much more work needed, partly from by us maybe, but also Apple should fix their drivers. So I have one driver, this is the GeForce 8 driver on macOS, and I just described it with the word hopeless. So yeah, a lot of fun with this stuff. Also, we have the testing was already mentioned. It's mainly for performance, and this is a picture generated from my hacky PHP script. I have a computer running 3D Mark tests every day, or whenever I turn it on. There was a huge skip during some time, and there was some performance regression which I have to find and investigate. But basically, we get a nice graph how the performance develops, and it should stay at least on the same level and not go downwards, and preferably increase. So the problem with the tests is that I started them, and once I had them working some sort of, I just lost interest. Okay, it works, so move on to the next problem. But someone, I think, so the idea is to move all of this over to CX test instead of my hacky script, and get some more test data. And you also need many more games to test with. Just to DMARC 2000 isn't really conclusive. So yeah, the Direct3D Summer of Code project was done by Andras Kovac, and I'm not entirely happy with the results. So the idea was to start the fundamental of Direct3D 10. What was needed was the header, then a stub library, just to have the function entry points there. And what we also wanted to do is to make sure that debugging is starting for debugging support is added. It's mainly just trace lines which write out the function calls and the parameter names, because Direct3D 8 and 9 have a big problem there. WinD3D can write the stuff out, but debugging Direct3D 8 and 9 is quite nice because we only get the calls that the application does, and we don't have all the garbage that WinD3D internal causes. So we have a application voice versus Wine call debug there. So we have the header. Andras has written the thunk. He sent it to WineDevel yesterday, and I have to review it when I'm back. And what was also part of the Sum of Code project, which isn't done yet, is writing some initial tests just to show that we can compile a Direct3D 10 application, that the application runs on Windows, and that our primitive application runs on Wine, so that we just can show, okay, at least it's working for us primitive thing. And that's mainly the d3d10.dll library. And we have also seen a few preparations for Direct3D10 in WinD3D. So DirectDraw stuff. The problem with DirectDraw is that we have it's software accelerated mainly. It runs on any semi-recent computer, but at higher resolutions only with low frame rates. So the idea was always to move some of the work into OpenGL. And the main problem with DirectDraw and 2D work is that applications just load loads and loads of data. And we needed something more efficient than the plain OpenGL functions. So Roderick used pixel buffer objects for it. And the nice side effect is that pixel buffer objects allow us to implement the Direct3D 10 memory management model, where a vertex buffer and a texture are essentially the same thing, more or less. And what we hope to do is to provide hardware-accelerated DirectDraw on Windows Vista, because Microsoft removed hardware acceleration there. And some games are slower than they should be. A word about the game performance we have nowadays is that the performance depends on two main factors. One is the driver, so when you have an ATI card, forget about performance. Although I hope the new driver gets better. And the other thing is the application behavior. If an application is rude to us, then we run at a few frames per second only. If it is nice, we get up to 80% of Windows performance is realistic in a nice application. Some games are faster than Windows, but the only one I've seen so far was Half-Life 1. And with it runs on 500 frames per second or 400 is pretty irrelevant. But 75% of Windows performance are realistic. And yeah, but
Linux is so much better at managing that.
yeah.
It's nicer on Linux.
Yeah, the memory management is much better, but from a graphics point of view, World of Warcraft is still noticeably slower. But I have to add that Windows drivers have a huge game database where they apply application-specific performance cheats, some optimizations, but some things are plain cheats where they lower the graphics quality that is rendered, so they gain a few more frames per second. Because usually gamers only see, oh, nice frame rate, I have everything turned on, but that the graphics driver just doesn't honor the nice graphics options, they don't see it. So, like on Wine, we have people who say, oh, nice, I have 8 times full screen anti-aliasing, it works nice performance, but that anti-aliasing just doesn't work on Wine, it's just ignored. Many people don't see that. So graphics drivers cheat in that regard. We have a few known performance killers, and we have. We'll try to sort them out in the future. But some of them are pretty hard, like Get to See, which kills my Empire Earth game, which I started hacking on Wine for. And there are some of them are really major issues when we try to map Direct3D to OpenGL. So now what do we want to do in the future? For one part, continue to work on DirectDraw to get proper DirectDraw performance in old games on old computers. So it's in the best case, I want to be able to play a 12-year-old game on 12-year-old hardware. Of course, the game Age of Empires 2 runs on today's hardware, although it's still slow. But preferably, I want to run it on the hardware that was usual when the game shipped. Also, Direct3D needs stabilization and cleanup in a few parts. And a big project will be Direct3D 10. Stabilization is mainly debug the drivers, find the bugs, and report them to the driver vendors. And if they do not respond, find a hacker workaround, or just tell the user to get a better driver. So the problem is that only NVIDIA cards work on Windows and Linux, really. And we have major problems with the ATI driver, and macOS is a hit-or-miss thing too. And I do not know how the Intel drivers perform with Wine. So I have some, yeah. I've never played with them myself. For one part, due to the lack of time, and I don't have any hardware standing in my room with that. So if I want to test it, I can just go to university and test it there. But I've never done so. So far.
One of the issues with the Intel hardware is that most of it is integrated in motherboards, so you can't really buy
a card for this. So we don't have much failure reports about them, and there are very few bug reports for crossover too. So I think they might work quite well, or the cards are just used really for gaming because they are slow, but they work for simple games or games which aren't graphics intensive. So stuff like Warcraft 3 works quite nice with them, but Bioshock rather not. And we have a huge number of driver-related bugs. And usually people say ATI is guilty when the driver doesn't work, but I have found that there are three cases of bugs. Some of them are in Wine-D3D, in just specific code paths of Wine, which are only used on ATI cards. Sometimes we abuse NVIDIA bugs, where the NVIDIA driver doesn't complain about incorrect shaders, where other drivers say, hey, that's a problem, there's a problem in there. And some problems are they're plain driver bugs. And there are a few other cleanups needed too, like the X server locking is pretty messed up. It was abused for a long time for synchronization of internal data structures, and parts of the code called GDI functions while holding the lock and deadlock in a multi-thread application. So we need some cleanup there. The plans for Direct3D 10 are to the first question with Direct3D 10 is, when do we want it? Because starting Direct3D 10 now somewhat collides with the Wine 1.0 plans. So perhaps we'll just delay these plans. But there's one thing about, when we have a Direct3D 10 implementation, we can provide Direct3D 10 support on Windows XP and earlier Windows versions. And I think this would have quite a bit of an impact. So we should discuss maybe what this could cause. It could just be ignored, but it could also make game vendors contact us and help us to improve the Direct3D support, or game vendors take our code and hack around bugs we have in there. And this would mess up the whole Direct3D stuff pretty much, because when games are buggy because they work around bugs in our application, then also Microsoft can't really change Direct3D because they have the game bugs, and when they change their code, they break the games. So it would be a question, what would happen if we have Direct3D 10 in, say, now 4 months? Although I think 4 months is only realistic if I start working on it now and I work full time on it, because we need the external interface of Wine-D3D has to be changed a bit to reflect the changes in Direct3D 10. And we need a shader compiler and shader sampler, and we need to add support for more shader instructions. And at some point we should look how to deal with OpenGL 3. Although the problem with OpenGL 3 is that the interface isn't finalized yet, so we don't really know what it will look like. So we don't know if in the worst case, we just have to restart over with a new Wine-D3D for the new OpenGL functions. But I think it should be possible without major problems to just use an object-oriented inheritance feature. So Wine-D3D is object-oriented. So we have the base class, which does the management, and an OpenGL OpenGL2 backend, OpenGL 3 backend. And the abstraction layers are there. They are there already, so it wouldn't even add a performance penalty. So as I mentioned, the question is, when do we start this? So there's some problems which we expect. One was discussed already, the documentation of DirectX, but I think we'll just continue the way we used to do it till now and just find games that are broken, find out why they are broken, and then write tests. We did that for years, so we can continue it that way. And also, we always miss ourselves, our deadlines, which we would like to have. So it all takes more time than we hope initially. There's a huge problem in the Wine core with games. It isn't Direct3D specific, but just it applies to all games. Essentially, I do not know all the details, so Alexandra will have more info, knows that better. But basically, Wine blocks a huge range of the 4 gigabyte address range of a 32-bit process. This is to load the built-in libraries to a specific address. And in the end, only about 500 megabytes, I think. Is that right? Okay, but only a pretty small address range is available to the Linux libraries to allocate memory, and many drivers just mmap the video memory into the address space of the application and then run out of address space. And in the end, we end up with a limitation of 100 to 200 to 300 megabytes of video memory, depending on the application and the driver. And this problem already affects ATI drivers quite badly, which is when you run a game on an ATI card, a complex game like World of Warcraft, it just freezes the whole computer somewhere. That's because the driver runs out of address space, doesn't check the result, and then gets some exception somewhere and freezes the X server, and dead. And macOS has that problem. On macOS, we have a partial workaround, the GL Apple client storage extension, which allows Direct3D to take over part of the memory management. So we can move the texture backup out of the rather limited address range that is available to the driver. And a proper fix, we don't know any really. Alexandre says that one fix may be to write our own dynamic linker for Linux libraries. So we can just keep all the memory free and load the libraries ourselves to the address we want them. But it's a pretty bad problem.
Do the drivers mmap the video memory
Yeah.
one big chunk?
It depends on the driver.
Because if you mapped it as one big chunk, then we could map that into the high address range.
Yeah.
But if it's mapping it as chunks and little chunks, then we wouldn't be able to detect that.
Would it be possible to get an extension that the Linux driver that would be the Linux driver?
The extension like client storage. Yeah, the problem is that client storage only fixes half of the thing, because usually when you create a texture in OpenGL, then the memory is used twice. Once for mapping the video memory and storing it in the graphics card, and once the driver keeps a backup of it in system memory. So if video memory is rather limited, and if it has to upload a new texture, it still has the backup, and it doesn't lose the texture data entirely. And with client storage, we provide the Apple OpenGL implementation with the memory for the backup. So we fix half the problem, but we still do not fix the video memory that is mapped in. So it. We use less memory from that limited place, but Wine can use the blocked range for heap allocated memory and so on. But it's a pretty messy problem. And yeah, one hope was that Win64 support would fix that, but as Alexandre said, Win64 support isn't there anywhere soon. And hardware vendors still ship 32-bit Windows, and all games are 32-bit, so even if we have 64-bit support tomorrow, it won't help us, because the applications are still don't use it, with very few exceptions. So the problem isn't relevant really nowadays. It can be worked around with the ATI driver, it can be worked around on Apple. And I looked at Half-Life 2, and we have about 80 megabytes of address space left. So it will get pretty tight soon.
You only need 640K, so yeah, it should be fine.
Yeah. And with the port of Direct3D to Windows, we found out that many games that are broken on Wine run without major issues on Windows with our code. So as Alexander has already said, Direct3D isn't a blocker anymore for most games. The main issue is copy protection and direct input. I'll mention this shortly later on. Also network support, some encryption libraries. It's not only Crysis, but also games like EVE Online. EVE Online works since quite some time, but it used to be broken due to Winrust or something like that. And last year sound used to be an issue, but Martin fixed that quite nice. So I don't think sound is a blocker anymore either. So Direct3D is Direct3D is just one part of the whole issue. Some side notes from other areas. Roderick asked me to mention OpenGL, but Alexander did it already. So one problem we had, Vitaly Margolin tried to fix direct input support, but there are some problems with X11 doesn't report relative mouse movements. So we can only get relative mouse movements by checking where was the cursor last time and where is it now. And if the cursor is on the edge, it can't move upwards anymore. So a lot of games are broken because you can't move, either the mouse is stuck in the middle because Wine warps it back to get relative movements, or the mouse or the game would need relative movements, but the game is not warped properly, so you can turn a bit and then the real X11 cursor hits the screen edge and then you can't turn again. But like this happens in Unreal Tournament, for example, or I think in Quake Wars too. There's something like that.
No, Quake was other problems.
Okay. And somewhat in the last days, it looks like this problem is of the difficulty of the windowed OpenGL problem too. But I do not know all the details about that stuff. Vitaly is the expert on that. Or Alexandra knows it. Yeah, I think I think that's the only real way to get that going. To add some support to Xorg to report relative movements. Vitaly tried to read the event device node from the mouse, and this was working for getting proper mouse movements events, but it was an architecture problem, and Alexander refused it, and it also brings some problems into Wine which the X server deals with, like support for multiple mouse devices on laptops. With the code, I could play with my external mouse, but I couldn't play with the touchpad and stuff like that. And I'm also not sure if all mouse types report the format in the same data type. So my touchpad doesn't have an event device node at all, so the event device driver wouldn't work with my touchpad. So all in all, we still have to use X11, but X is too limited, so we have to extend it to somewhere.
The problem posed to one of the X-hackers, like, I don't think so.
No, not yet really.
Well, I think I know Omer. I think he talked to the XR guys.
It did?
Well, it was still X3 back then, but I think he did talk with them about that a few years ago.
Roderick has some contacts to X developers, and he said he could talk to them too, but we have to find out first what we really need there.
I think the idea was...
Yeah, it's easy to say, but in detail when you're going to implement it, and I think the Xorg developers will need more information probably. And there are other issues too, like focus management and so. And yeah, this is one of the main blockers nowadays for games, that you can't move the mouse properly. So I just wanted to mention it. I do not really know these areas. I just wanted to bring them up because neither Roderick nor Vitaly are here today. So yeah, that's it pretty much, just some summary. I think Wine has a pretty solid and high-performant Direct3D implementation nowadays, but it still needs some parts to be cleaned out, and there are still bugs in it. It's not perfect yet, but it's pretty solid. And the next big problem, before 9.0 or after, we don't know yet, will be Direct3D 10, of course. We have almost everything for Direct3D 9C. The only thing that is missing is those are predicates in pixel shaders, but we haven't found a game yet which uses them. And there's also something called displacement maps, but I do not really know, honestly, what this exactly is. And I haven't found a game using them either. So those are two things that are just aren't used. And one other feature is is in my tree, which I've only a very hacky patch for. So, but this also is only used by DCD. So we are pretty much Direct3D 9C complete nowadays. But the problem is that many drivers do not support some features in Linux, although they do it in Windows. So the high-end stuff only works on NVIDIA cards, business as usual. So that's so far pretty much my status update. Any questions? I didn't have. Oh, okay, that still works. I didn't have any resolution changing bugs recently. There used to be some 1 year ago, especially when the game changed the resolutions in game, or when the game had some window decoration set, so we have to remove the window decorations. And there's one problem in DirectDraw, because DirectDraw on Windows always draws to the screen. So if the game goes full screen, draws to DirectDraw, and puts a window in front of its DirectDraw target window, the DirectDraw drawing still appears on the window because it just overdraws everything. So, and we draw to the window to get X11 clipping properly. There are some problems due to screen drawing in Windows 2, which can be shown with some demo applications.
Yeah, I do actually think that some games, like Battlefield 2, for example, they still got some issues with resolution changing.
Okay, so.
And what happens is that the graphics in the game itself get messed up.
So Henry says there's still some problems with resolution changes. I personally haven't seen any such problems lately. Yeah?
Different question.
Yeah.
Is it okay to ask now? I was more interested in those performance bugs. What are you going to do about those?
Yeah, there were some frame buffer objects performance regressions lately, and I caused a performance regression in shaders. The shader regression should be fixed already. This was just, I fixed some bug. Okay, while I'm at it, I'll fix it, but I haven't seen a game yet which hits that. And it caused constant recompilation of shaders. So the patch was correct, but I reverted part of it because no game had the problem yet. And however I'd solve this, we would have a performance regression. So I just
How about those long outstanding issues like get DC, draw styles, etc.?
GetDC could be partially fixed with the device-independent bitmap engine, but it wouldn't solve the problem with OpenGL, because with GetDC, DirectDraw, DirectX applications can use GDI commands on the graphics card's back buffer, and we currently handle this by downloading everything into system memory, passing it to the X server, drawing there, and then uploading it back. And the download and upload to the GPU it's pretty slow. With high-end cards, it works properly, but it's still slow on older cards and Radeon cards at least. I once tried to implement hardware-accelerated GDI drawing by writing my own GDI driver in Direct3D. And we do not need much. All the games do with GDI on the back buffer is drawing text. They just use one function and that's all of it. But there are some architectural problems, like that the the DirectX device context and usual window device context have to be in the same driver. I can't implement it in a different driver, because the application has to be able to do a bit build copy between window and Surface. And my driver broke that ability. And yeah, so essentially, Windows implements Direct3D in the GDI driver. So to get this properly working, we would have to move Wine3D into X11 DFV, WineX11.DRV. So that's not really a nice solution either. So I do not have a fix really. Another idea was to create an OpenGL accelerated BixMap, and to copy the BixMap would be NVIDIA memory. So copying from the back buffer to the BixMap is cheap. And then it pass the BixMap to the server and say, draw me there. And then the X server could theoretically just draw in the card, and the X server could do the job. But I do not think the drivers really support that. So it would still be slow, but we just say, oh, we are innocent. It's the X server that makes things slow. So what?
The draw stride is slow.
Draw stride is slow is a problem with the color format. The format of colors in vertices is different, and DirectX and OpenGL have the red and the blue channel swapped. So before drawing vertices with color information, we have to swap them. And this is done in draw stride slow, where we send vertex by vertex by vertex to the card. Instead of telling, hey, here are 100 vertices, draw them. And this issue is mostly fixed by fixing the color in the vertex buffer and storing it. But it still happens if games draw a huge number of vertices of dynamic geometry from the memory. But there are pretty few games that are really limited by that. And mainly it's old games. And old games on new cards are fast enough anyway, mostly. There are some exceptions. And on old cards, draw strided slow is faster than draw strided fast. This is on really old cards, like D&T2 cards. So I think draw strided slow isn't really a killer problem anymore, but some games are still affected by that.